Good afternoon, everybody, and welcome to this latest in our series of Open to All webinars. Thank you very much for attending this. And today we're going to be talking about maximum safe handling temperatures for bitumen. It's an important subject, and it's important that we understand why we have established maximum safe handling temperatures for bitumen, where they have come from, and what we can do to ensure safety when handling bitumen. So let's start with a very basic review of the handling of bitumen itself. In most circumstances, bitumen's handled hot. It's handled at elevated temperatures. We consider if we're making using bitumen to make an asphalt mixture, then the temperature could be probably anywhere between 150 to 180 Celsius typically. If we're loading bitumen from a refinery or a terminal or a depot into a delivery vehicle, again, we could be operating at temperatures significantly above 100 degrees. And the transportation of bitumen at above 100 Celsius classifies bitumen as dangerous goods. And there are certain legislative requirements that require us to place labels on onto the delivery vehicles, identifying that this is dangerous goods. It's also important that we understand the implications of handling bitumen at elevated temperature, at high temperature, because the bitumen itself is not inert. It does react under the effect of temperature and air, and that will cause it to age. What does aging mean? Well, in essence, it means that the bitumen becomes stiffer. It becomes more brittle, and the extent to which that happens is largely governed by the temperature at which it's handled and the amount of air which is introduced to the bitumen itself. So if we're handling bitumen at very high temperatures and we have a lot of air around, then the chances are that we're going to cause a significant amount of aging to the bitumen, and that means the bitumen itself is going to potentially become more brittle. So we need to understand the implications of that from a product quality and consistency perspective, but then also we need to understand that within the bitumen itself, bitumen is a very complex mixture of all manner of different hydrocarbons, and when some of those hydrocarbons are exposed to heat, they can start to come out of the bitumen matrix itself, and they can emit into the environment. So we do get emissions from bitumen. They can come out of the bitumen into the environment and can cause, for example, exposure of those emissions. Workers handling the bitumen and handling, for example, an asphalt can be exposed to those emissions. So we need to understand the temperatures at which those emissions occur and how we can manage the effect of those emissions. Well, fortunately, Eurobitume has a number of technical guidance documents, and one of these refers to the safe handling of bitumen at elevated temperature. And within that, you can see an extract in front of you on the screen right now. And it talks about the maximum safe handling temperatures for various bitumen grades. And what we have done within Eurobitume is we have classified bitumen into effectively two groups. So we have our paving and air rectified bitumens with a maximum safe handling temperature of 200 Celsius, and severely oxidized bitumens with a maximum safe handling temperature of 230. Now, I will come to a description of air rectified and severely oxidized bitumen in a moment, but it's just important at this stage that you understand our guidance divides bitumens into paving grades and into severely oxidized grades. Okay, we make a very clear distinction of that between those two products, two families. Sorry. So you may not be familiar with what an air rectified bitumen is. Well, it's a bituminous binder which is, shall we say, mildly blown. We correct some of its properties, or we modify some of its properties by blowing a gentle stream of air through it. And that has a number of effects. It tends to increase the ring and bore softening point, and it tends to decrease the penetration. So it effectively produces a slightly harder bitumen than you would have from the original. And we do this for a number of reasons. In terms of the properties of air rectified bitumen, they are similar. They are very, very similar to a conventional straight run bitumen, a bitumen that is just taken from a distillation column. And indeed, the air rectified bitumens have the same CAS. They have similar properties. Sorry. The process used to produce them is very similar, although much, much less aggressive than the processes that we would use to produce a severely oxidized bitumen. But because an air rectified bitumen is subject to the same sort of process, then they have a similar CAS registry number. So how do we differentiate between our severely oxidized bitumen and our air rectified bitumen? Well, we do it via a concept known as the penetration index. And I will come to that later. So let's just refresh our memory about the various manufacturing routes that we have to produce our bitumen. So this is just a schematic of the things that would be involved. The first step is that we would bring our bitumen in our crude oil into storage tanks, and then we pass through a furnace and into an atmospheric distillation column. So we heat it up. We take some of the more volatile products out in the atmospheric column. We take the residue, we put it through another furnace, we heat it up, we put it into a vacuum distillation column, and then we generate our straight run or paving grade bitumen. And that could be the end of its journey. But we may want to undertake other processes. So we can take that paving grade bitumen and the straight run bitumen, and we can blend it with polymers, and that can then be taken away and distributed to end users. Or we can push that straight run bitumen through an oxidation unit, and we can produce either our air rectified or our severely oxidized bitumen, and then that can go away to the end users. I suppose just to reinforce the critical difference between our air rectified bitumens and our severely oxidized bitumens, although they use very similar processes to produce them, the products themselves are completely different. The oxidation process used to produce a severely oxidized bitumen is much more severe, much more air pushed through, and the products coming out are significantly harder. They have higher ring and ball softening points, and they have much lower penetrations than you will get with an air rectified bitumen. So it's very important that you understand the difference between those two products, even though when you first look at it, you might think, well, they're broadly similar, but they're not. They're two distinct products. So let's have a look at what the penetration index criteria really means. Now, penetration index is a well-established mechanism of determining the temperature susceptibility of any unmodified bitumen product. Okay, only really works for unmodified bitumens. It doesn't work for anything else. We have classified the different families, so air rectified bitumen and severely oxidized bitumen, according to penetration index. Now, our air rectified bitumens have a penetration index of less than 2, and our severely oxidized have a penetration index greater than 2. And it's a well-established protocol to do that. You don't need to get particularly caught up in the mathematics of how it's worked out, but it's determined effectively from the ring and ball softening point, as defined in EN 1427, and the logarithm to base 10 of the penetration as determined according to EN 1426. As I said, it's a pretty old calculation, but it's still very well established and is particularly useful in allowing us to differentiate between these two product families. So that's how we differentiate between those two families of products. Let's dig a little deeper now into the background of the maximum safe handling temperatures. I mentioned right at the start, temperature has a very significant influence on the aging of bitumen. When we handle it hot, the hotter we handle it, the more potential distress we apply to the bitumen itself, and the more aging that we tend to induce into the bitumen. But that's not the only thing that we need to consider. Temperature also has a very significant effect on both the amount and the composition of emissions. So those are the substances which can be released from the bitumen at elevated temperature and come into the atmosphere and potentially cause exposure to workers handling the product. So it's important to remember that the temperature at which we handle bitumen doesn't just affect the amount of emissions, doesn't just affect the volume of emissions that are coming off bitumen. It actually affects the composition, and it's very important that we remember that. So it changes the chemical nature of the emissions as well, the higher up that temperature range we go. However, if we stick to the recommended ranges that we have established for safe handling, it's very likely that exposures of emissions by workers will be within regulatory limits. Each individual country across Europe and indeed across the world will have established exposure limits for various chemical species, and it's very likely that if we stick within those recommended limits for safe handling, that we will meet the regulatory limits or be below the regulatory limits. So that's a very positive thing to take from this. And it's also very unlikely that exposure to those emissions from the hot bitumen will cause any hazard to health. So we have two things to remember there, that if we stay within the limits, We're unlikely to compromise any regulatory limits that are established in individual countries, and the emissions are also unlikely to present hazards to health. So there is a well-founded reasons that we establish these maximum safe handling temperatures. So let's have a look at what temperature does in relation to the amount of emissions. Now, it's quite a busy graph here. There's quite a lot to take in. The scales are maybe a little bit unusual to you, so I've tried to simplify what we're plotting here. And in effect, what we're plotting is the amount of emissions or the volume of emissions on the vertical axis against temperature on the horizontal axis. This graph was established for a paving grade bitumen at 5070, and there is data for a whole range of different temperatures. Bear in mind that the amount of emissions, that vertical axis, that y-axis, the scale there is logarithmic, so you can see a significant increase in quantity of emissions or volume of emissions as we move up and up and up that temperature scale. So we go up very significantly for relatively small increases in temperature. So the amount of emissions that are released is affected very significantly by the temperature that we handle the bitumen at. If you want more information on this, can I suggest you have a look at a joint publication between ourselves and within Eurobitume and the Asphalt Institute. It's a fantastic publication called The Bitumen Industry: A Global Perspective, IS 230. There's a reference on the slide there. It's available on our website. It's also available on the Asphalt Institute website. Go and have a look at that. It will go into more detail about the temperature effect on the amount of emissions. What about the composition of emissions? This is possibly a little bit more difficult to understand. Here the scale is the temperature scale is a little bit easier, and I've just marked on there our reference point of 200 degrees for paving grade and air rectified bitumens, and 230 for severely oxidized bitumens. In this case, the y-axis is what's known as the carbon number endpoint. Now, the best way to think of that is really how big the molecules are in the emissions. And what we find is, as the temperature goes up, we get more high boiling point material. So we get bigger molecules coming out into the atmosphere as the temperature goes up. But what the graph doesn't show is that we get an increase in what we call the 4 to 6 ring PAHs, and those are the chemical structures that you can see on the right hand side of the slide. PAHs, polycyclic aromatic hydrocarbons, have the potential to be carcinogenic. So as the temperature goes up and we release more of these PAHs into the emissions, we are releasing more and more potential for carcinogenic materials to be exposed, workers to be exposed to those carcinogenic materials. Again, there's much more detail of this in that IS 230 document, the Bitumen Industry Global Perspective. I do recommend that you go away and have a read of that. We'll talk in much more detail than I can do today about the temperature effect on bitumen composition, on the composition of emissions, sorry. So summarizing that, coming back to what we said right at the very start, the maximum safe handling temperatures for bitumen and air rectified bitumen are 200, and for severely oxidized bitumen, it's 230. And you can see underneath that, there's a sentence that says use above these temperatures is advised against in the bitumen REACH dossiers. Now, conscious that we have people on the webinar today that are not operating within Europe, REACH is a piece of European chemicals legislation. It talks about the registration, evaluation, authorization of new and existing chemical substances. And when this legislation came into place, we had to all actors in the chemical supply chain, whether it's bitumen or anything else, had to submit dossiers demonstrating that their products were safe. Okay, and also had to identify specific uses and guidance information. And within that, we would say that these are the recommended handling temperatures for bitumens. Operating outside of those limits, above those limits, then that is what we call a use advise against. We don't advise use above those temperatures, and it's not included in those REACH dossiers. So, do we just say if we operate at, if we keep our paving grades to 200 degrees and our oxidized grades at 230 degrees, that's enough? Well, no, not really, because what we want to do is we want to ensure maximum protection of workers from exposure. And the biggest single thing that we can do in reducing exposure and protecting the workers is reducing the temperature. You've seen from those graphs what happens as the temperature goes up, both the volume of emissions increases and the composition of the emissions increases as well. So what can we do to reduce that exposure? Well, the single biggest tool that we have is to keep the temperatures low as practically possible. And that will have a significant effect on both the amount and the composition of the emissions. We can also carry out hazard and risk assessments for each individual workplace. We might want to consider if we're working, for example, if we're working indoors, laying a mastic asphalt in a car park or something, or a situation like that, how that compares to working in the outdoors, placing a conventional asphalt mix. So it's important that we carry out risk assessments and hazard assessments for each individual workplace. And then there are some other things that we can do. We can look at engineering, organizational and protective measures or controls that we can use to further mitigate exposure. So we do have a lot of things that we can use. I just want to go into a bit of an explanation of the hierarchy of risk and hazard reduction measures. And there's a well-established inverted triangle of controls to reduce risk. The most effective, almost without exception, is elimination. And that's to physically remove the hazard. Now, so for us, that would mean we have bitumen and we eliminate it. So we take bitumen away from the asphalt mix or producing the roofing membrane or the mastic or whatever. And of course, for us, that's impractical because we would simply be left, if we're making an asphalt mix, we would be left with some uncoated aggregate, and that's not going to work for anyone. So elimination is something that we can't do within our industry. We can't eliminate. And it's the same for a lot of industries as well. The next thing we can do is a process of substitution. So we can replace the hazard. Now, that might mean moving from a hot mix asphalt to a warm mix asphalt to a cold mix asphalt. So we're mitigating, we're substituting the hazards presented by temperature, and we're going to lower temperatures, so we're substituting the hazard. It's a pretty powerful technique. The next layer of effectiveness comes with our what we call engineering controls. And these are things that we can do to isolate the people, the workers, from the hazard itself. Common examples of that would be things like local exhaust ventilation. If you're working in a lab with bitumen, you can do all of your blending and handling inside a fume cupboard, and that takes away the emissions and takes them away from the workers. So we engineer it out. It's still effective to do that. Less effective are what we call our administrative controls. These are things that where we say that we want people to change the way they work, and an example of that could be job rotation. It could be introduction of rest periods. So if we're producing an asphalt mix, we might want to rotate the roller driver and the paver driver so that they are not exposed in the same way, and they can be removed from it. We might want to introduce mandatory 10 or 15-minute rest periods where workers can move to away from the paving operation, get some fresh air and some water, etc., and rest. And then we come to PPE, personal protective equipment, which involves protecting the worker. If we can't do anything else, so we can't eliminate, we can't substitute, we can't engineer, we can't do our administrative controls, then we rely on PPE. And I think it's important for anyone in the industry to remember that sometimes we can see PPE as the most important thing, the most effective thing. It isn't. When you look at the hierarchy of controls, PPE is the last resort. If you can't do anything else, then you look at PPE. And PPE could involve it could involve face mask, it can involve anything like that. So what do we have in terms of our engineering controls, administrative controls? Well, in terms of engineering controls, there's a number of things that we can use. We can, for example, institute ground-based truck operations. If we have a truck driver who's delivering bitumen to a coating plant or an industrial waterproofing plant, we can engineer out the exposure by stopping the driver having to go to the top of the tank, his delivery vehicle, to vent it. We can do that from ground-based, and that's the direction of travel within the industry at the moment. It's preventing that exposure by engineering it out. There's all sorts of remote operations that we can carry out that allow you to open tanks and vents from a distance. There are simple things like understanding wind direction. And this comes into our hazard assessment per workplace. If we know which direction the wind is blowing, it makes sense for us to place our workers away from where the wind is traveling, so the emissions will be carried away from them rather than towards them. And then, of course, we can introduce our local exhaust ventilation. I'm aware of some manufacturers of asphalt paving equipment where they have ventilation equipment above the screed, and it just conducts the emissions away from the screed and therefore away from the workers. In terms of administrative controls, there's not a great deal that I can add to what I said earlier, other than we can consider job rotation, moving people around the job site, or if you're in a refinery, moving them around so exposure is minimized. And then we come back to our PPE, our personal protective equipment, which could, in certain circumstances, include things like respiratory protection. So those are the things. Those are some practical things that we can consider. If you want more information on this, on safe handling, guidance, and documents, we have a lot available within Eurobitume, covering the whole bitumen supply chain, if you like. Go onto our website, www.eurobitume.eu, and then click on the publications section. This is from our new website, which has been live since June. Up in the top corner, you will see here this area marked publications. If you click on that and then come down here, and in this little search bar, search for what you want, and that will produce all of those documents that you want. So what is the critical takeaway from this? We have established for bitumen and air rectified bitumen through research that our maximum safe handling temperature for bitumen and air rectified is 200 degrees Celsius, and for our severely oxidized bitumen it's 230. These temperatures have been derived from a number of scientific studies, and there are references in that IS 230 document that I spoke about earlier on. And as a result of that, use above these temperatures is advised against in our REACH dossiers. I just want to explain what that really means before we close. It means if you choose to operate above these temperatures, then that use has not been assessed, and so by the manufacturer, and then the user then needs to assess the risks that are associated with that formally, notify the authorities of what they're doing, and most importantly, ensure the safety of workers. Now, I can't stress this enough, that we should operate within those maximum safe handling temperatures of 200 for bitumen and air rectified bitumen and 230 for severely oxidized bitumen. So that's an introduction on our maximum safe handling temperatures. If you need more information, please go and have a look at our website. There's a whole host of information there, not just on safe handling, but on almost every aspect of bitumen. So do go and have a look at that. Contact details for the Eurobitume team are on the slide in front of you. Please feel free to reach out to us via phone, email, or WhatsApp, and we will do what we can to assist you. So thank you very much for your attention today on the very important subject of maximum safe handling temperatures for bitumen. I'm going to end the slideshow now. I'm going to hand back to Siobhan. Thank you for your attention.